All right, lesson 8.2 is titled Demography, which is defined as our use of statistics to track the changes in human populations. And so we know that we have increased our technology in order to keep up with our population growth, to up our carrying capacity. But we also know the way that logistic growth works and the way that ecology works, we are likely to not be able to continue this indefinitely. At some point, we're going to have to make a change. So demographers who study demography look at these several characteristics: size of the human population, distribution, so where are we located and how are we located, age structure, how old are the people in different populations, the sex ratio, what's the ratio of men to women in each population, as well as the population rate of growth, so the rates of birth, death, emigration, and immigration. So right now, the current population size is about 7.3 billion. It's spread amongst 200 nations. So in the UN, which we've talked about, predicts that by 2050, the global population will surpass 9.7 billion, which is insane. So if you look here, China's at 1.37 billion, India 1.31, and they predict that India is about to, or will surpass China in population size. The US is the third largest country in the world via population, and we have 1 billion less people than both India and China, which is really crazy. So 1 out of every 5 people lives in China on the planet, which is kind of crazy. So there's lots of other factors that determine environmental impact besides size. So that's why we were talking about those other things like distribution, age ratio, all of that. So this picture talks about the prediction in world population growth. We'll come back to this later. So we talked, one of the things that affects the impact on the environment of each population is not just the size, but also the distribution. So the highest human densities are found clumped around temperate, subtropical, and tropical climates, which makes sense. So we're clumped where it's warmer. China, Europe, Mexico, Southern Africa, and India fall into those areas. And population density is lowest in the areas that are with extreme climate biomes, and such as the desert, rainforest, and tundra. So in the deserts around here, we see less people. That's not really a desert. Down there's a desert. The tundra, we see in the rainforest, we see less people. It's highest along seacoasts and rivers, which makes sense because before we had the automated ways to travel, people clumped around the water because they could get from place to place. So this is population distribution. Then we also have what are called age structure diagrams. You have seen these before. So the data on age structure is particularly valuable to demographers that are looking to predict future growth. So they're visual tools to illustrate age structure. The width of each side is the number of individuals in each age class. So down here, this is 0 to 5, 5 to 10, et cetera, et cetera. And on either side, this is another number of males and number of females. So these are just models. These are not actual countries, but these are models of populations that have particular trends. So this one would be a population increasing rapidly because they have a lot of young people and a fewer number of old people. This would be a pretty stable population. The number of old people and the number of young people are pretty stable. Down here, this would be a population decreasing because there are far fewer young people than there are old people. So one of these is likely to grow very quickly. This is about to stay the same. This will probably decrease. And here's 2 real life examples. So Nigeria is on the right, and that is a rapidly increasing population size because there are so many young people at pre-reproductive age or at reproductive age, and that's where we're making more people is in those ages, or will be making more people if it's in pre-reproductive age. Whereas on Canada, the Canada age structure diagram shows that they have the majority of their people in post-reproductive age, which means they are not making more people. So that might likely be one that's going to stay the same or decrease. So the global population today is older than in the past 10 years. Today, the global median age is 28, but by 2050, it's predicted to be 38. I'm sorry, your book says 38, this says 35. So the median age is getting older. That means if you lined up all the people and picked the middle age, it's not the average, it's just the middle one. It would be, today's 28, later it would be 38. This is creating a social strain because on social welfare, like on Social Security in the US. I don't know if you've heard of this, but Social Security is something that once you start working, you pay into. That way, when you stop working and retire, there's a fund to help you live after you stop working. And that's creating a big problem because there are far fewer people accepting Social Security today than there will be in the future. And so it's not sustainable. What's next? So we have discussed a lot of long-term benefits associated with smaller populations, but a lot of policymakers or people involved in the government find it difficult to let go of the idea that population's growth means a more powerful, economically successful country that could have a large military. So there are opposing sides. That would be that divergent view on population growth again. So we're going to talk a lot about China and India in this chapter. So China and India are struggling to get their population growth under control, but there are still some countries that are trying to increase their population. It's not on this slide, but talking about how they're providing incentives for people to continue to have children, and these are things such as extended maternity care, subsidized childcare, so like daycare for your kids, and tax breaks for larger families. In China, there's been a cultural gender preference for male children combined with the one-child policy that we talked about and read about. It's resulted in about 116 Chinese boys are born for every 100 girls. It didn't say this in the last slide, but it has been the global average has been 106 boys born for every 100 girls. And the reason for that, the hypothesis is that it's a little bit of an evolutionary advantage because boys are more likely to die at any given point in their life than girls are. So evolution has adapted, and now there's just a little bit, a 0.6% higher chance that you're going to have a boy. But in China, it's 116 boys for every 100 girls. Some hypothesize that in specific areas in China, it's actually 138 boys born for every girls. And so the leading hypothesis of that, unfortunately, is that parents are determining before birth that their kid's going to be a girl and selectively aborting females just because of cultural differences, that boys are favored as children. It's just traditionally valued sons over daughters. So here is a age structure diagram of China in 1970. You can see it as a rapidly growing country. It looks very similar to Nigeria, lots in pre-reproductive age, lots of reproductive age, and a much smaller amount in post-reproductive age. In 2015, it's leveled off a lot, far fewer in pre-reproductive age because of the one-child policy. Still a lot over here. You can see the trend is still happening from over here, and they predict that in 2050, it will have leveled off a lot, and it will be a country that's decreasing in population size. Okay, so, and then all this population change that we're talking about comes from birth, death, immigration, emigration. If you remember that equation from the beginning of the year, the population growth rate equals births plus immigration minus deaths plus emigration. The number of people coming in via being born or immigrating minus the number of people leaving via death or emigration will give you the change in population. And so we talked about this last lesson, but there's been a global decrease in infant mortality, and this has played a huge role in the population growth. So again, at first, babies were dying very young. Healthcare was much worse. That's basically it. It was due to poor nutrition, disease, and exposure. So historically, people would have lots and lots of children because they wanted to make sure that they had enough to live past infancy, and that's not happening anymore. In a lot of developed nations, it's still happening in undeveloped nations. So people are just having fewer kids because the infant mortality rate has decreased. So infant mortality rates, they've noticed, are closely tied to a nation's level of industrialization. So if we look at this graph first, we can see that there's no data from Greenland, but infant mortality rates per 1,000 live births. So for every 1,000 births that happen, these are the number of babies that die. And so in the US, it's 6 to 10, Canada 1 to 5, Europe 1 to 5, Russia, Eastern Europe, and Eastern Europe, 6 to 10. Again, in Mexico and South America, it's 11 to 20. Australia, 1 to 5. And then we see this region right here, which is much less industrialized than the rest of the world. And we can still see high infant mortality rates. In this region of Africa, it's still 76 to 100 out of every baby, every 1,000 babies are die, which is 7.6 to 10% of babies, which is crazy. But one example of this is that China saw its infant mortality rate drop from 47 children per 1,000 live births. So 4.7 kids, 4.7% likely that your baby was going to die in 1980 to now only 1.6%. So as they've industrialized, they have really, really decreased their death rate. This is a trend that we've seen amongst other developing nations. Okay, so in recent decades, falling growth rates of many countries have led to an overall decline in the global growth rate, which makes sense. So our global growth rate has declined. However, we are still increasing very rapidly because we're still increasing. So even though the growth rate is decreasing, we're still adding 88 million people to the planet every year. And this is primarily due to a steep drop in birth rates. So, and we'll talk about that in a minute, but you can see over here that the growth rate really depends on how developed your country is. So our global population is still increasing. It might not be increasing as quickly as it had been. So if we're talking math, the slope has slowed down a little bit over here. It's less steep than it was down here. So the growth rate has changed. This is the world's growth rate, the blue one right here. So it has dropped as well. You can see that the green is the more developed regions. The growth rates are much, much less. Then we have the red is the less developed countries, and the orange is the least developed countries. So they haven't really seen a drop in birth rate at all, whereas the more developed regions really have seen a drop in birth rate. Europe's birth rates are down. Europe's population is decreasing. And then immigration and emigration also significantly impacts the population of individual nations. Like the US is one that has a relatively low compared to other countries' birth rate, but we have a really high immigration rate. So that affects our population as well. Then we talk about something called total fertility rate, which also influences population growth. And what this is it's the average number of children born per woman during her lifetime. So basically, how many babies is each woman having? The replacement fertility rate is the number of babies that keeps a population stable. This means that if you keep up with the replacement fertility, the population size will not change. And that number is 2.1. That is because if you think couples, okay, because women are having babies, but men are needed too. So every couple would need to have 2 babies to replace the mom and the dad. And then there's that 0.1 to account for an unexpected infant mortality. So 2.1 will keep a population stable. So if every woman has 2 1/10 of a baby, obviously it's an average, we're not having 1/10 of babies, that will keep the population stable. But industrialization, improved women's rights, and healthcare have decreased the fertility rate in many nations. So for example, in Europe's fertility rate is very low. Women are just not having as many babies as they were before. So worldwide by 2015, 84 countries have fallen below the replacement fertility level. So there's 84 countries in the world that are not having 2.1 babies each. So you would think that we would be staying stable, but because there are some parts of the world where it's super high, it's averaging it out and we're still having an increase. So Europe's natural rate of increase, which is changed due to birth and death rates alone, so not including migration, so just what's the percentage of growth due to births, was between 0% and 0.1% in 2015. So they were increasing very, 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 very slowly based on births. So you can see in Africa, the total fertility rate is 4.7. So that means that each woman is having on average 4.7 babies, every single woman. So that means that there's those who are having one or two, there's those who are having 8 or 9, probably.